In this video, we're going over more debugging techniques. This time we're focused on logic errors. Logic errors are problems with the algorithm that you write. It's when you write an algorithm and you haven't completely thought everything through, or you've written the algorithm correctly but haven't correctly interpreted your algorithm in Python. And so your program runs just fine and Python doesn't produce any error messages, but your program just doesn't create the expected output that you were looking for. So it's not solving exactly the problem that you were intending to solve. So you know that you have this type of error when you run your program using one of your test cases that you've created. Remember, when you're creating a program, you always design test cases that you're going to use that sample input and then the expected output for those particular input values. And so you run it with one of those test cases and you just don't get the output that you were thinking that you should get. So we're going to talk about some ways, some strategies that you can use to find logic errors in your program. The absolute easiest way to get feedback from the computer is to ask it to print some extra information to the screen. This is information that's probably not required output for your project or the lab that you're creating, but it would allow you to display or see useful information that would help you to think through the intermediate steps in your algorithm so that you can view kind of what's happening as your program progresses from beginning to end and help you locate the problem. Whenever you folks email me code, a lot of times if the error doesn't jump out to me right away, this is the technique that I use to locate the problem in your code. So let's go through an example together. Suppose that we wrote this Python program and it stores information in a list called quiz score list, and then we wanted it to print out all the quiz score values. Coded everything up in Python, looks good to us. We get ready, we compile it, and we use a test case that we've designed. Unfortunate line break here. So we designed this test case where we're going to include these 10 values, 98765432110 as our quiz score values. And then we're expecting it to print those as the stored values in our list. So the score at position 0 is 9. The first number we enter, the score number that's at position 1 is 8. And then score at position 2, 7, and so on, all the way down to the score at position 9 is 0. So that's what we were expecting to get as the output. Let's see what we actually get when we run this program. So I coded it up in idle so we could see it live on the screen. So when we run the program, if we type in our input values 98765432110, it's printing out 9999999999999. It's just going on and on forever. I'm going to say restart the shell because that'll make it stop running my program forever. So instead we get this output. Again, it's just printing 9 over and over and over again forever. So we know we have a logic error because the actual output that we got doesn't match our expected output. So the first thing you can do is just look at your code and be like, hey, is anything jumping out at me? Let me kind of mentally trace through this, think about all my algorithmic steps, think about is this a problem with the input? I'm asking them to enter a score, I'm appending the new value, I'm adding one to the count, and then I have this other loop where I'm printing things out. If the error jumps out at you right away, that's fantastic and you can go ahead and fix it. If it doesn't, then you could add a print statement to print out the contents of the list after the first loop. That would allow you to figure out hey, is the problem with the input or is the problem with the output? So if we wanted to add a print statement to our program after the input loop, that would go right here, kind of in the middle of our screen. And we don't need this to be super fancy output because we're just using this to test out our program. It's kind of just for us, the coder. So we could just print out quiz score list. And we don't need it to be in a fancy format or have a label or anything. We could add a label in there if we wanted to. Sometimes if I'm going to do a lot of print statements, I add a label so that I can help keep track of where is it printing each value. So I do something after the input loop, here's the value of the quiz score list. And then we can run our program again, see what happens. Again, I'm going to use my sample input. And now I see that it printed after the input loop and it had the right values in there, but then it just was printing crazy in the output loop. So it looks like the problem's not with our input loop. if we're going to focus our attention, we want to focus it on all the statements that follow our print statement after the input loop. We know that down here, that's where the coding error is occurring. So that technique can help you to isolate what's going on in the program. Again, kind of show what that looks like in the lecture notes. So now you know that it's happening in the loop that prints things out. You might be able to, once you know that, think through the second loop and realize like, oh, it's never moving to the next value in the list. If you look at this, it's always printing the score at position 0, the score at position 0, the score at position 0. So it's never changing the value of the counter. And that's because the counter update step is not indented. So Python doesn't think of it as being part of the loop. So if you indent that, add that in there, and then run the program, I think you'll get the right behavior. And sure enough, so now we get the statement that prints after the input loop and everything's right, and we got our expected output from the second loop as well because we made that correction. Now, after you make the correction, you can go through and put a comment in front of any extra print lines that you added. That'll allow you to easily add those back if you need them for debugging purposes later in your coding process, but it won't allow those to print out to the screen. So if there's like a required output format for your lab or for your project, you won't have those extra statements that you added to help you during the debugging phase. So in this video, we reviewed some techniques that you can use whenever you're debugging your code. Again, if you find that you have a logic error because your output doesn't match what you expected, Python's not giving you any syntax errors or runtime errors. It's usually because you haven't coded something correctly. You haven't successfully transformed the ideas that you were hoping to incorporate into your algorithm into your actual Python code. And those statements, print statements, can really help you by allowing you to see the progress of the program as it's executing and allow you to zero in on the area of the code that might contain the error. Another good tip when you're debugging is to only write a few lines of code at a time. So for example, if you had written this while loop and then added a print statement at the end just to make sure that you were making good progress, then you would already know that this first part was working before you started coding the part that printed the output loop. And so that's another good tip. I try to write like a maximum of like 5 to 10 lines of code at once before I run the program and get some feedback about whether or not it's working. Even if I'm not ready to print the final output that my program's calculating, I try to think about what kind of output could I provide to myself right now that would provide me with reassurance that I'm on the right track and making good progress towards the solution. Hope these tips were helpful to you and that they assist you in your coding adventures as you're completing the final project and lab.